So guys, we are discussing about the motion, right? The types of motion, that is completely constrained motion, successfully constrained motion, and an unconstrained motion, correct? So in the last class we have already seen what are the definitions of these motions. That is, completely constrained motion means the motion is constrained by the system itself, right? Means no third link, no other link is going to constrain the motion of the second link, right? So that is a completely constrained motion. And what about the successfully constrained motion? It means the motion of a link is constrained by one more link, the external link. So that will be known as a successfully constrained motion. And an unconstrained motion means what? It is not constrained at all. Means more than one motions are possible for a link at a time, right? So now let us see few more examples. Already we have seen some examples for completely constrained motion and a successfully constrained motion. For example, a square shaft in a square hole, that will be a completely constrained motion, because the motion means the rotation of the shaft is constrained by the shape of the hole, which is a square hole, right? So the system itself is constraining the motion, that is why it is a completely constrained motion. And also we have seen that the shaft inside a rotation of the shaft, correct? Because rotation of shaft, the reciprocation is constrained by what? The flange which is fixed or attached to the shaft, correct? So reciprocation is constrained by the system itself. As it is fixed, you cannot consider flange as a third link, right? It is the integral part of the shaft itself. That is why the rotation of the shaft is also considered as a completely constrained motion. And what about successfully constrained motion? What example we gave? The motion of the piston inside the cylinder. The rotation of the piston here is constrained by what? It is constrained by the connecting rod which is connected to the piston using a pin joint or a hinge joint, right? So that is the successfully constrained motion. Now let us see few more examples for the successfully constrained motion and the unconstrained motion. After that we will go to the kinematic pair. What is a kinematic pair and how it is classified, right? So guys, now let us see few more examples based on the motion, successfully constrained motion and unconstrained motion. Shaft in a footstep bearing. What kind of a motion is this one? See here, this is a successfully constrained motion, but why? The reciprocation of this particular shaft is constrained by what? The engine, right? The load that is applied by the engine, or the engine that is connected to the shaft, will prevent the reciprocation motion of the shaft, right? So only rotation is there, and as the engine is a third link, so this comes under the successfully constrained motion, because the motion is constrained by a third link, some other link that is constraining the motion, right? Now what is an unconstrained motion? More than one motion is possible. A cylindrical object inside a cylindrical or the circular hole, correct? Cylindrical object that is placed, it can reciprocate also and it can rotate also. So two motions are possible at a time, so it is not at all constrained. That is why it is an unconstrained motion. Now what is the kinematic pair? See, any connection between two links connected, it can be a pair, but to define it as a kinematic pair, the pair must be such that there is a constrained motion between the two links. See here, between links is a constrained motion. any connection between two links is always a joint or a pair, but this pair will only be a kinematic pair when the relative motion between the links is a constrained motion, as we have seen here, right? The relative motion must be a constrained motion, then only you can call it as a kinematic pair. Now classification of kinematic pair, how the kinematic pairs are classified according to the relative motion between the links. For example, is the link between when two links are connected by some kinematic pair, is one link sliding, right? Sliding over another link, or turning inside the other link, or whether is it rolling on the other link, like this, rolling on the other link. So like this, based on various motions which are possible, we can classify the kinematic pairs as follows. Turning pair or revolute pair or a pin joint. You have already seen the hinge joint or a pin joint. If it is joined by a pin joint, there is only one motion which is possible, that is pure turning motion. One link turns inside the other link, like this pin joint connected, right? Pin joint. One link can only turn inside the other link. An example that you can take is a see, the door hinges, the door which is moving, right? Rotating, because it is hinged at a point, right? So there is a only turning pair is there, hinge, latch, right? Now what is a sliding pair? Sliding pair, or it is also known as a prismatic pair. When one link slides over another link, there is a sliding contact is there. So such kind of a pair is known as a relative motion, is a pure sliding. So that kind of a pair is a sliding pair or a prismatic pair. See, first one was the turning pair, second is a sliding pair. Now let us see what is the rolling pair. Means one link rolls over another link, just rolling motion, right? The motion of roller you have seen, that is rolling on the road. Relative motion will be a pure rolling. What do you mean by pure rolling? There is no sliding or skidding over the surface, so that will be a pure rolling. If that is the case, it is known as a rolling pair. For example, take a ball bearing, right? There is an inner race and an outer race. Let me call the inner race as the link 1, outer race as the link 3, and in between them the balls are placed. Now what is the connection between first and second link? The second link is rolling over the first link, that is why 1 and 2 are connected by a rolling pair. Now what about second and third? Second and third also there is a rolling motion happening, so that is why even that is a rolling pair. And what about first and third link? First link and third link, first one is turning inside the third link, that is why 1 and 3 is connected by a turning pair. Now what is a screw pair? It is nothing but when the relative motion is over the threads, just like nut and bolt arrangement. Nut and bolt, nut is turning inside the bolt, so our bolt and nut combination is known as a screw pair, because one is turning over the threads of the other, right? When the relative motion is over the thread, it is known as a screw pair. And what is a spherical pair? Just like a joystick, if you take one link is having a 3D rotational motion, right? 3D rotational motion over the other link, then it is known as a spherical pair, or the spherical joint or a spherical pair. So there is a 3D rotational motion over the another link, right? So this is the classification of various kinematic pairs based on what? Based on the relative motion between two links. Right? Now, further we will be seeing the classification of the kinematic pairs based on other factors also, like how they are in contact, line contact, point contact, surface contact, and so on. Right? So let us see them. So students, now let us see the few more different kinds of pairs, kinematic pairs, based on type of contact and type of closure. Right? So what is this type of contact? See, when there is surface contact between two links, when there is a surface contact, for example, a turning pair, you can take turning pair, means two links are joined by a hinge joint. Turning pair has a surface contact. Sliding pair, when one link is sliding over the other link, the sliding pair also is having a surface contact. Right? When the contact is a surface contact, then it is known as a lower pair. Example, pin joint and a sliding joint. When the point or line contact is established between two joints, right? Between two links, there is a point or line contact. For example, take a rolling pair. When a cylinder is rolling over a surface, what kind of contact is there between a cylinder and the surface? There is a line contact, right? And when a ball is rolling over a surface, there is a point contact. So a rolling pair and point contact. For point contact, example is the ball rolling over the surface. For line contact, an example is the cylindrical roller rolling over the surface. So both are the examples for a higher pair, because the contact established is a point and line contact. Now what is a wrapping pair? Now one link is wrapped over the other link. For example, belt is wrapped over the pulley, right? So that is a wrapping pair. When one link is wrapped over the other and the belt is wrapped over the pulley. This is the example for that. Now you need to observe one thing here. The belt wrapped over the pulley, you cannot consider it as a surface contact, because the deliberately some friction, to attain some friction, the roughness will be provided between the belt and the pulley, right? Because of that roughness, there will be a multi-point contact and not the surface contact. Everywhere there is a multi-point contact will be there to achieve some roughness, because we don't want the belt to slide over the pulley, correct? Because of power transmission. So there will be a multi-point contact. It is close to the what? Higher pair only. Now let us see. The further, one higher pair is equals to two lower pairs. Why? For example, let us take a cam and follower arrangement. So now tell me, how many links are there in this arrangement? There are only 3 links. You may see 4 links here, but there are only 3 links. What is that? One is a fixed link, right? So this is also a fixed link. This comes under one link only. Wherever you see this sign of fixation, that is only one link. Now fixed link is connected to what? Cam, right? And cam is further connected to the follower using a higher pair. See here, only point contact is there, so it is a higher pair. And this follower is reciprocating, correct? Inside the first link here. Now this 3-link mechanism, because of this higher pair, if you want to replace that higher pair with the lower pair, you have to use 2 lower pairs to replace one higher pair. Why? Its equivalent mechanism, if I draw it, it will become a 4-link mechanism, not a 3-link mechanism. See here, a crank is there, it is rotating, and there is a rod which is connected to this reciprocating part. So this will provide me the same kind of motion from rotation to translation motion, correct? So to obtain this one, there is a requirement of one extra link. One extra link means two lower pairs are there on that particular link. See here, one lower pair, another lower pair. So two lower pairs are needed extra to replace one higher pair. Now, according to the type of closure, how the two links are closed. If there is a forceful contact, it is a force closed pair. What is this forceful? Sorry, what is this force closed pair? Take a door closure. When door comes and closes, attaches, automatic door closing mechanisms, right? When door comes and closes by itself, that is a forcefully, there is a contact is established. It becomes a pair only because of some force. There is a forceful contact is there, and higher pair in cam and follower. See here, this is a cam and follower mechanism, correct? What kind of a contact is there between this cam and follower? There is a forceful contact. The moment the force is released, the contact is disengaged, correct? So that is why this contact can be established only by the application of some force. So it is a force closed pair. Now what is a self closed pair? Permanent contact is there. For example, you take again a hinge joint or a turning pair or a sliding pair. There is no need of any extra force to establish the contact. So that is why it is known as a self-closed pair, right? So the remaining part again we will discuss. So students, now let us see what are the different types of joints. A binary joint, ternary joint, quaternary joint, and so on. How they are divided based on how many links are getting connected to that particular joint, or that particular joint connects to how many links from itself, right? A binary joint is a joint to which two links can be connected. If two links are connected to any joint, then it is a binary joint. If three links are getting connected to any joint, then it is a ternary joint. Now here is a formula. One ternary joint or a ternary pair is nothing but it is also equals to two binary joints or binary pair, right? See, why one ternary pair is equals to two binary pairs? Because this can be obtained only by joining two times. See, for example, first link and second links, I will join it first. One joint, right? Means one binary joint is there. Now a third link will come and connect to any of the joint, any of the links using one more joint. So there are only two binary joints are there, two binary pairs. So similarly, quaternary joint, four links are there in the quaternary joint, and one quaternary joint is equals to three binary pairs. Just reduce by one. Ternary, just reduce it by one. 3 minus 1 is 2, two binary. Quaternary means four links, reduce it by one, three binary pairs. Now what is a kinematic chain? See, links are arranged in such a way that first link is connected to the last link, and relative motions between the links is a constrained motion, right? Constrained and predictable motion means if you move one link, other link is going to move in this way. If that is the case, it will be a constrained motions. Then it is known as a kinematic chain. Right? Now what is a linkage? If any of the links of this kinematic chain, any link, if I fix it to the ground, then I will obtain a linkage, or it will become a mechanism. It is same as both the things, linkage or a mechanism. Sometimes kinematic chain also we will call it as a mechanism itself. Based on different authors will use different conventions. So linkage is nothing but this kinematic chain, one link fixed to the ground, it will transfer the motion, it becomes a linkage. Now what is a redundant chain? It is nothing but a chain does not allow any motion between the links. See, for example, 3 links I am going to join by pin joints. If I move any of the links, any one link, then other link is not going to have any motion. So this is a redundant chain. No motions are possible. Now any of the links in this redundant chain, if I fix it to the ground, it will become a structure or a locked system. Right? Fine. Okay, in the next class we will discuss about the mobility or the degrees of freedom of a mechanism. Right?